In this slidecast, we'll consider the implementation for hash map. Here is the definition for our hash function class. Okay, it's defined as a struct. It takes a reference to a key type as an input parameter. And here's the specialization for strings. It takes in a string, and here's the computation of the formula we saw earlier in this chapter, where we take the prime number 31. We can take each character in the string and do a multiplication and an exponentiation to generate a fairly unique, a good random distribution of hash codes for various strings. Now, using an int value as a hash function doesn't tend to distribute the keys evenly. A better approach is to multiply the int value by a large prime number and take the modulo. So here's a specialization for int. Now, to use objects of our own classes as keys in a hash map, we define the equality operator, the equals to, and specialize the hash function class. So the hash function is used to start the search, and the equality operator is used to finish it. So the hash function must obey the following contract. If object 1 is equal to object 2, then the hash of object 1 has to equal the hash of object 2, where object 1 and object 2 are objects of type. And you should make sure that your function uses the same data fields as your equality operator. So class person has a data field ID number, which is used to determine whether two person objects are equal. And the equality operator returns true only if the object's ID numbers have the same contents. And here's our overloaded equality operator for class person. Now, to satisfy its contract function, the hash of a person must also be specialized as follows. Because we want two person objects that are equal to have the same hash code. Now here, the hash map iterator and the hash map const iterator are defined. Here are some data fields. Here's a pointer to the hash map that this iterator is iterating through, and the index in the table for the current entry. Here's some public member functions and their behavior, and some private member functions. Why don't you pause the slidecast and study these functions and their behaviors. I'm not going to read it all for you. You can study that at your own pace. Now, the const iterator must provide a public constructor that converts from an iterator to a const iterator. And here's the definition of that constructor. It takes a hash map, a reference to an iterator, to a hash map as the parameter, and it initializes the parent and the index from other. And the other constructors for iterator and const iterator are private because we do not want the client programs to create arbitrary iterators. And the only valid iterator objects are ones created by the member functions of the hash map that owns the iterator. So iterator and const iterator classes, they must declare hash map as a friend, and iterator must also declare the const iterator as a friend for the conversion constructor that we just described. And that brings us to the end of this slidecast.